we're looking at a composition of functions. A composition of functions is where we take one function and plug it into another function in order to build a new function. With that being said, there's two different types of notation. The first notation is F composition of G. I know it looks like an O, but it's actually not. And what this means is that G of X will get plugged into F of X. So whatever number or whatever letter is on the right is the one that goes first. So what exactly does this mean? So let's say that F of X equals 3x plus 4 and G of X equals x squared minus 2. So if I were to find the composition based on what I have above, that G of X function goes into the F of X function. So because the F of X is on the outside, that's what we know as the outside function. So it's now going to be 3 parentheses, whatever G of X is, in this case it's x squared minus 2 plus 4. So it's kind of like a system in which we use substitution in order to solve for a variable, except we only have one variable. So now we've got 3x squared minus 6 plus 4, and we simplify to give us 3x squared minus 2. And that is our composition of functions. Now, you could go the other way and vice versa. So let's say that we do go the other way and I want the composition of G of F. So now this 3x plus 4 gets moved into this x spot. So now we have 3x plus 4 in parentheses squared minus 2. Now caution when you do the square. And I say that because a lot of people will go 9x squared plus 16. That's not actually how it is. It's 3x plus 4, and I list it twice to make sure that I distribute properly. This is where a lot of people jump right to that 9x squared plus 16. They forget about when you actually have to distribute that you're going to have a middle term. Sorry, I should have done that in blue. So we actually have 9x squared plus 12x plus 12x plus 16 minus 2. So we can go ahead and simplify that and combine our like terms to give us 9x squared plus 24x plus 14. And that's the composition of G of F of X. So you can see here that the composition, they give you two different answers, and that's because of the way that you're plugging the function into the other function. It doesn't always have to be two different functions. You could plug F of X into F of X. You could also do this with a number. So for instance, if I wanted the composition of f of 2 of G, instead of using the x values, you go with the number value. Personally, what I do is I go through the whole thing first as an x, and then I plug in the 2. So looking at this, our f of x gets plugged into G of X. So we have negative 4 times 2x plus 3 minus 3. I'm going to go ahead and distribute. So I've got negative 8x minus 12 minus 3, which is negative 8x minus 15. So now that I've got it simplified, that's when I go through and plug the 2 in. And the reason why I do it this way is that way I don't get something goofed up if I plug the 2 in right away. So I now have negative 8 times 2 minus 16, or minus 15, sorry, I'm already doing the multiplication in my head. So now we know that we've got negative 16 minus 15, which is going to give us a negative 31. So that is how we do our composition of functions. Like I said, it doesn't always have to be two different functions. It could be the same function. They could plug in a number, or it could be general like this.